All right, everybody, it's Friday. I'm on the bike and boat trip, and there are a few new things I want you to try. Today, I want you watching this video about geometric series, about summations of geometric series, and then trying a handful of problems. The work and the descriptions are inside of Schoology. You could simply click on the Schoology agenda for today. Today is day 170. I'm looking at my computer, day 173. And you can find the page number and the question numbers using your online textbook. All right, here we go. So quick version of this. A geometric series is just a series of numbers that has the same rate. We talked about that making it geometric. So 10 divided by 5 is 2, 20 divided by 10 is 2, 40 divided by 20 is 2. So we have a common ratio. So in this case, the common ratio is 2. That's one of the things that you'll need to know or to be able to calculate using a geometric series. You'll see that R value shows up in a variety of different places. It shows up in all three of the different formulas that we're going to work with. So no matter what we're dealing with, we're going to be dealing with that R value. So knowing that R value is going to be valuable to you, or if you don't know it, finding it will be valuable as well. We have three different things that you can do. One of them is to find a particular value. That's this one on the left. If you want to find a particular value in a sequence, let's say the nth value in a sequence, then you literally just take the starting value, you multiply it by your ratio, your common ratio, and then you take it to the power of the number of the term minus 1. And we'll look at an example of that in just a minute. If you're trying to add a summation, if you're trying to add up a geometric series that is finite, and by finite, I'm going to use this example up here on the top. Finite means it only goes to a certain length, and then it stops, right? This sequence on the top, this series, maxes out at 20,480. That is finite because it doesn't continue on. If you're dealing with the summation of anything that's finite, you're going to use this formula. And if you're going to do something that's infinite, now infinite is strange, right? Infinite, if we took this and we kept adding on, we would keep getting bigger and bigger and bigger numbers, and we would keep adding on and on and on, and our sum would keep getting bigger and bigger and bigger, and we would not be able to find the sum of that series. However, that's not what this third formula is actually doing. This third formula is saying, what if we have something that is converging towards a number? It's getting closer and closer and closer to something like it's getting closer to the number 1, or it's getting closer to the number 0, or getting closer to the number 7. If it's getting closer to something each time, that converges towards that value. Even though there's an infinite number of those values, we can actually calculate the sum, and it looks like a pretty simple formula. So let's check out how to do these three things with three examples. I'm going to start with the third example first because it's the easiest one. This one is that example where we are converging. All right, and we're converging because we're going from 2, which is our first value, and we're getting smaller and smaller and smaller each time using a common ratio, right? If I want to think about my common ratio, I'll just use a different color. 1 divided by 2 is 1/2. So 1 divided by 2 is 1/2. 1/2 divided by 1 is 1/2. 1/4 divided by 1/2 is 1/2. So the common ratio is 1/2. All right, so we know our starting value and we know what our common ratio is. And by the way, that ratio can be positive or negative. It doesn't matter. So we come down here and we go the sum of all of these numbers the whole way to infinity, which is pretty crazy. But think about what would happen, right? These numbers keep getting smaller and smaller and smaller. They're converging on 0. This particular pattern is converging on 0. So at some point, the 100th or the 1,000th or the millionth term is going to be so teeny, teeny, tiny that it's not really going to be changing our sum very much. So what we're going to do is we're going to say our sum is the first value over 1 minus the ratio. So in this case, the sum is 2 over 1 minus 1/2, which is 4. So we can very quickly calculate the sum of this converging infinite geometric series with a very simple formula. So if you're ever asked to do that, that's the way you do it. Your starting value over 1 minus your rate, or your ratio, I mean. All right, let's go backwards to number 2 now. Now, number 2 has a similar setup to something that we might have done earlier in this week with arithmetic series. It has this thing called sigma, if you haven't seen this before. The sigma symbol is this funky looking kind of E-shaped looking symbol. And sigmas have a starting and ending point. The starting value is going to be the number of the term that starts down here, and we're going to go to this term up here. And the way these always work is it's going to, next to the sigma, it's going to give you what the pattern is. And what you would do is you would take the first value, that's this guy down here, right? You would take the first value and you would put this number in the end spot. So you can see that I did that here, 2 to the 1/4 to the 0. And then what you would do is you would go to the next one. Well, the next one after 0 would be 1, and we put it in, again, we put the 1 in. And then you do the 2, then you do the 3, then you do the 4, and you go the whole way up till when you hit the number 20. So we keep going the whole way up to number 20. And if that makes sense to you, we're going to have all of these values. There are 21 terms that we're going to add together. Now, while we could do this with brute force and just calculate this value and calculate this and calculate this and do it 21 times and then just put them all into a calculator and add them together, and we could do that, oh my God, we don't want to do that because it's going to take forever. So instead, we have this formula right here, which is how you calculate the sum of a finite series. Finite means it ends at some point. Ours ends after 21 terms. The sum of a finite geometric series. So here we go. The sum of a finite geometric series, we have 21 terms. We get that because from 0 to 20 is 21, because we count the 0. So we're going to go with the first term. All right. In this case, our first term is whatever we get out of the first value that we get when we put our starting number in there. So let's see, 2 to the 1/4 of 0, that's the same as 2 times 1, so that's just 2. So we know this first value is going to be 2, so let's get rid of all this stuff. So let's see, in this value, instead of a sub 1, we're going to go ahead and put a 2. Instead of 1 minus r to the n, we're going to go ahead and 1 minus, let's see, what did we say this was? This value right here, if you can see it, this value right here, the 1/4, that is our common ratio, because that's what it's changing by each time. So we're going to go ahead and say that's our common ratio, and that common ratio is going to be taken to the number of the terms, right? Our n value is the number of terms we're going to have, and we've already established that we're going to have 21 terms. And on the bottom, we have 1 minus r. 1 minus, and we've already established that it's 1/4, so here we go. Now this is absolutely a calculator task. There's no doubt about this, and this thing, I'm going to go ahead and say that if we put this into our calculator, let's see if I can find my calculator tool here. Let's give this a second. Let's get this synced up. And this is where you grab your calculator or your iPad calculator, although they're not as convenient. And here we go. We're going to do on the top, I'm going to do 2 times 1 minus, now 1/4 I'm going to put in parentheses, and I'm going to take that 1/4 to the 21st power, and then I'm going to go to the right and close that parentheses off. And then only because I'm a little bit nervous that I didn't put parentheses around the whole top, I'm going to press equals, and then I'm going to go ahead and divide by the 3/4 that's on the bottom. So I'll press equals, I'll divide that by the 3/4 that's on the bottom, because 1 minus 1/4 is 3/4, and I get my result of 2.66. So that's it, right? My sum is 2.6, repeating, I bumped the screen there, that's why the log showed up. So it's 2.6 or 2 2/3, or what is that, 6, 7, 8 thirds. So lots of different ways you can answer this question, but that is the sum of this funky thing. All right, we're just using the formula. All right, final piece. I'm going to leave this calculator there because we might find ourselves needing it, but I'll get it a little bit smaller. All right, here we go. In this question right here, we're trying to find the sum of this long list of numbers. This is definitely a finite sum, but my issue on this one is while I know what my starting value is, so S sub n equals 5, and I know because we did this already that my rate is, or my ratio, 10 divided by 5 is 2, 20 divided by 10 is 2. So I know that it's 1 minus 2 to the n value and 1 minus 2 on the bottom. My issue is I don't know what term to go to. I don't know if this is the first term and this is the second term and this is the third term and this is the fourth term. We don't know what term this is. And could I grab a calculator and just figure it out? Sure, but that kind of defeats the whole purpose. So since I'm kind of stuck at this point, I'm going to leave that there, and I'm going to go over to something else instead. I'm going to use one of my other formulas. I'm going to say that we know that a sub n, we don't know what the n is, but we know that a sub n is the 20,480. So a sub 1 r to the n minus 1. So I'm going to say 20,480 is where this pattern stops. Our first value in the pattern is a 5. Our rate, we've already established, is 2. I keep saying rate, it's a ratio. And look what we have here. So we have this thing, I'm going to zoom in. We have this thing right here, which we can solve pretty easily. I'm going to divide both sides by 2. By the way, don't do this. Don't multiply 5 times 2. That's not, you can't do that. So divide both sides by 5. And I'm going to use a calculator here. 20,480 divided by 5 is 4096 equals 2 to the n minus 1. All right, I'm going to go ahead and use logarithms here because I have an exponent in a variable in my exponent, so logarithms are the way to go. So I'm going to do log of 4096 equals log of 2 to the n minus 1. I'm going to remind you that if you have something up here, you can move it to the front. Great. And then I'm going to find myself dividing by log of 2, which is very much going to be a calculator task. The log of 2 cancels out, and I'm going to get n minus 1 equals, and my calculator again. So log of 4096 divided by the log. Remember, you're going to use the math button and then go over to the right on your calculators. And we get 11.989. Oh, I typed it in wrong. Let's try that again. So second entry, I meant to do 4096, and I'll re-enter. Oh, I did it wrong again. Holy cow. Let's try it one more time. See if I get it right this time. 96. All right, double checking. There we go. All right, and I kept checking because I knew what the answer was supposed to be, so I knew something was a little bit out of whack. And we find ourselves saying that n is 13, right? So we can calculate n, we can calculate how many terms there are, and then that will help me over here on the other side where I was kind of stuck, because now that I know that there are 13 terms, I can go ahead and put in this guy. And I'm going to use my calculator again. I'm not going to pretend anything otherwise. So 5 times 1 minus 2 to the 13th power, close parentheses, and 1 minus 2, I already know that's just negative 1. So whatever my answer is, I'm just going to make negative or make opposite. And my answer is negative 4095. So I end up with this, negative 40955 over negative 1, which means 40955. And there's my sum. This is a rather long video for sure. I'm not there in person to kind of coach you through this. So what I'd like you to do after you've now survived this video is use these 3 formulas. I'm going to scroll back up. Use these 3 formulas in creative ways. You're going to be working on, I'm looking in Schoology on my computer right now. I'm looking at the agenda. You're going to be on page 599. And you're going to be working on questions 9, 13, 16, 19, and 38. These are written down in your agenda. And keep in mind that some of these, the odds, of course, are going to be in the back of the book. So if you want to start with those so you can have an answer to check with, go for it. If Mr. Gaitis allows you to work with a partner or partners, that's fine, but don't be disruptive. And if he needs you to work quietly so he can focus on his class, then, well, please respect that. I'll see you on Monday if you're not on the bike and boat trip, and good luck.